Students who are fortunate to study life science and chemistry at the same time, some of the theories they can connect nyana here and there. So here is our question for today. We'll be doing question 2. We have the diagram that has substances. So the substances that we have is substance P, Q, and R. We can see the given substances on the given blocks there on the diagram. Underneath, we have the key that shows the nature of each and every element that is connected to the substance. I've mentioned the element now, and I've mentioned substances. Here's the thing. We are told, like I say, students who are lucky or fortunate enough to do life science, they know that all living organisms are made up of cells. So they say, right? And we have plant cells, we have animal cell. And within the cell itself, we go inside and break it down until we get to DNA, we can even describe the RNA and stuff. We go deep. That's the fun part of life sciences, right? Which is biology. But what are cells made up of? So now it takes me to the breaking down of the initial fundamental particle that we can think of that makes up everything. So the building blocks of everything in nature, everything on earth is made up of atoms. Now, the weight, you can call it atom, you can call it an atom, depending on your accent, but I'm talking about the atom. And an atom is the building block of everything. So everything is made up of atoms. So now, for this question here, right, we can see this is not life science. This is chemistry. And in chemistry, we have the so-called periodic table of elements, whereby all the natural elements are collected and grouped in one table. We all know the periodic table. I'll find a space somewhere in the screen to show you what the periodic table is, but we all know what a periodic table is anyway. So now, the periodic table is the periodic table of elements. All those elements in a periodic table are made up of atoms, because atoms is the natural building block of everything, because even cells themselves are made up of atoms. I've gave out enough information to can answer each and every question that is given here. Oh, before I I have. We can go with the question. Number 1, 2.1, they want us to define what an element is. Define the term element. Straightforward. You can go to your dictionary, not a dictionary, maybe Google search. You can go to your Google search and say, what is an element according to chemistry? But an element is a pure substance that is made up of only one type of an atom. So if we look at our question again, we have the key. The small circle represents hydrogen. Now, that's a hydrogen atom. And then we have oxygen, we have sodium, we have chlorine, we have sulfur, and we have iron on the keys that makes the elements that we have up there. So the definition of the element, an element is just, actually, let me get the right one according to Google. It says it's a pure substance made up of one type of an atom. That's an element. So like I say, the periodic table is now then the collection of elements that are made up of atoms. Now, 2.1, you just write that. That's how you answer it. I can't write anything down. An element is what it is. So I think you'd get a full mark if you can say an element is a pure substance that is made up of only one atom. Yeah. So now use the diagram and the key provided to answer the equation that follows. Now, let's analyze our diagram before we answer the questions. The first substance is combination of it's only 2 circles that shows hydrogen. So it's a combination of tiny two hydrogens. And then substance Q, that's for substance P. Substance Q, we can see the sodium and chlorine combined together. We can think of some sort of sodium chloride there. And then we have oxygen also on substance Q. If you look very well, there's the black ball, and then we have it attached to two hydrogens. That's like H2O. So we have two hydrogens bonded to oxygen. That's more like water, if now you understand where this is going. And then we have the third one, substance R, is the combination of sodium and no. There we see iron combining with sulfur. Yeah, maybe a bit of sodium as well because of the way it's arranged like that. So, but no, it's sulfur and iron, I think. Yeah, sulfur and iron as we see it. But fine, that's what we have, right? And now 2.2.1, we have to determine if, okay, fine. But now the main question is to write down the letter that represent the following. So for 2.2.1, we must show the letter that between substance P, substance Q, and substance R, we must show the letter that represent pure substance for 2.2.1. Let me just, between substance P, substance Q, and substance R, you can see that obviously substance P consists of hydrogen only. As much as it's bonded like this, it's 2, 2, 2, 2, 2 of each, but it's just hydrogen only, as you can see from there. So it's clearly that substance 2.2.1, the purest substance of them all from the three substances that we have, substance P is the pure substance, you see. Now, substance 2.2.2, they want us to determine which one of the substances is a homogeneous mixture. Let me pause there and explain something. So far in chemistry, we're going to talk about two types of different mixtures, two types of mixture. Whether should it be liquid, whether should it be solid, whether it should be gas, it doesn't matter, but we have two types of mixture. We have homogeneous mixture, we have heterogeneous mixture. Homogeneous mixture, heterogeneous mixture. Homogeneous mixture is a mixture which, with your own eyes, you can't differentiate the particles that are mixed there. Whether should it be substances, whether should it be particles, whatever it could be. Homogeneous mixture, you can't differentiate the components that are inside. And then we have heterogeneous mixture. Heterogeneous mixture is when you can see with your naked eye what is mixed in that solution. You can separate the components by looking at them. You can even separate them by saying, oh, I have a mixture of this and that. That's a heterogeneous mixture. And I'm 100% sure as we speak, I'm passing some images so you can understand the view of heterogeneous and homogeneous mixture. So homogeneous mixture, you can see the pattern in terms of the images is arranged in order of some sort. It forms a beautiful pattern that shows you can't really tell the difference on the components. Whereas with heterogeneous mixture, from the images that we are seeing, you can tell that one is organized such that it would be easy to separate. The other one, which is homogeneous, now you can't really separate the two. Now from the images, obviously you can tell that substance Q is organized in order like that. We have a combination of sodium and chlorine going together. We have combination of water there. So we can see it's a solution mixed with water and sodium chloride. And from the diagram itself, it's bonded in an order that we can tell like, that's a homogeneous mixture. But unlike substance R, there's variety going on there, even the distance between the bonds. So now to answer 2.2.1, it's safe to say 2.2.2, the homogeneous mixture from these substances is going to be substance Q. Therefore, 2.2.3, 2.2.3, the heterogeneous mixture, which you can tell or it would be easy to separate, it would be R in that order. So for 2.2.1, 2.2.2, 2.2.3, it's P for pure substance, Q for homogeneous mixture, and R for heterogeneous mixture, as shown in the diagrams there. 2.3, the question states, indicate whether the pure substance identified in question 2.2.1 is an element or a compound. Sharp. We then say a periodic table consists of collection of elements, right? A periodic table consists of collection of elements. Now, the elements react together to form compounds. So those elements in a periodic table, they bond together, they react and form different types of reactions and bonds and form compounds. Now, when we have a compound, is when we have more than one element of different atoms. A compound is when we have more than one element of different atoms. We can have 5 elements of the same atom. We can't really say it's a compound. Okay, well, it could be a compound in that case, but look, we have the so-called what do they call it? The diatomic elements. Diatomic elements, they exist in, they have two atoms in nature. We have, it's like 7 of them. I'm gonna try to put the diatomic elements here, but it's just to remember that atoms like this exist as two atoms, something like that in nature. So now you don't write hydrogen as H when you write, like for instance, if water, because hydrogen and oxygen are both diatomic. Let me just give a quick example. The formation of water is when hydrogen bonds react with oxygen, right? This is how we get water. So when hydrogen reacts with oxygen, we get H2O. But now to balance this now, because we have 2 hydrogen and 2 oxygen, I'll put 2 here and then I'll put 2 here. So then I'll have 4 hydrogen atoms and 4 hydrogen, but this is the balanced equation. However, when I start, I represent hydrogen as H2. You don't state you don't write hydrogen as this in nature, because it's a diatomic, it's represented by this. So obviously, if you have one atom like that, in nature, it means it will be like this. But although it has 2 atoms, it's still an element because it's just hydrogen element as it is, nothing nothing combined with it. So here we have an element, hydrogen, here we have an element, oxygen, but then here we have a compound, water. So water is a compound. So an element and element reacted together to form a compound. So H2, regardless of the fact that it has 2 atoms, so it's diatomic because it exists in the form of 2 atoms in nature, it's still just hydrogen. So for 2.3, I will then say the element that was discovered in the element that was identified in 2.1.1 is an element. I mean, the pure substance that was discovered in 2.1, which is P, is an element because it's just hydrogen element. It's not a compound. 2.4, we have to state which physical method would you use to separate the substance Q into its component. How can you separate the substance we have in Q, the water and the sodium chloride? You would probably have to boil it so the bonds can break down and one of the substances will evaporate. Like, let's just say evaporation is the process you're going to use for 2.4, because as you boil it, as it evaporates, because of the density of the gas form of each one of the components, each one will be arranged into its own form. So just by oiling it, and then it starts evaporating, and then that's how the components can divide themselves like that, the bonds can break. So you can say for 2.4, evaporation is the process you're going to use to separate the components in substance Q, because it consists of water and sodium chloride anyway. And then 2.5, quickly, because time now, write down the physical property upon which the separation techniques are based to separate the following substances into their individual elements for Q and R. Like I say, 2.5 for 2.5.1 to separate the substances Q, you'll have to evaporation is what we said. So we said 2.4 evaporation. We said evaporation is the method we would use to separate the substances in Q. But how do you initiate evaporation? You have to boil. So we'll say boiling point because they have different boiling points. Boiling point. And then 2.5.2, we have a combination of sulfur and iron. One of them is an ion. So obviously, if you can use magnetism, you can separate. Magnetism can separate the substances because you can just use a magnet to attract the other one into its positive, and the other one would be left as it is on the thingy, wherever the system is. You know, with chemists, like I understand with physics, guys, now with physics, we'll always find ways to simplify things. Also with chemists, we'll always find ways to simplify things. But at the end of the day, now you must put some efforts, dog. You gotta study, you gotta prepare. We are here. You can send us your question whenever you get stuck as you are preparing for your exam and whatsoever. Here is our email address, info@simplifiedrsa.com. Also, we are open for private lessons for those who need assistance in private lessons. Our contact numbers are here. Please contact us should you need any help with private lessons. Otherwise, we'll offer the first lesson for free so you can tell if you feel like we are helping you or not. So you won't have to like go on and work with us if you feel like we are not what you are looking for, because we have a whole range of different types of people who offer the services that we offer in different ways that they do. But I feel like we are the most better compared to anyone you can think of in the world. But anyway, please follow us on our social media platforms as well. Follow us on YouTube, follow us on TikTok, follow us on Facebook, follow us on Instagram, and as well as Spotify. What else am I missing? Yeah. Until next time, I'm Mr. Maimane. This is Simplified RSA, and we are the guys who makes it looks easy.